Okay, everybody, it's the top of the hour, approximately 8 a.m. Pacific Standard Time, 10 a.m. Central Standard Time, and we've got Bjarne Stroustrup on the line. Bjarne,
hello.
Are you there?
Yeah, I'm here. Can you hear me?
Yeah, I absolutely can hear you.
Good.
And can you see, I'm sharing my screen with some slides that I've put together just to keep the conversation moving along, and also for people who are watching to see some of the links and some of the questions, so it makes it easier for them to try to understand what I'm saying, or the crazy.
Yeah, I see a title and a picture of me sitting at my desk.
Yeah, that's from your...
Which is some kind of recursive joke, because I'm sitting at my desk watching it.
Excellent. And there's your homepage, stroustrup.com.
Thanks.
Okay.
Yeah, if I look up, I'll see that picture behind my head. It's pretty odd.
And I'm just going to go through these for everybody who's welcome to this session with Bjarne. We're not going to go to all these links. I just wanted to put them up there. One of the famous ones is you pronouncing your name for everyone from the Danish. I can't do that. My voice doesn't work that way, or my throat doesn't work that way.
It's good. When I do it, people don't believe me anyway, but if it's on the web, it must be true.
Yeah, there you go. And then some additional links about your books. And also, maybe we could start the conversation. There's this new foundation, isocpp.org, that we're working to join as Embarcadero. It's a nonprofit organization, and you're one of the several directors of the foundation, right?
Yes. It was an idea primarily Herb Sutter's idea, coming from my comments that C++ never had an organization. And back in the dark ages, I tried to make a C++ foundation, but I didn't have the right sort of organizational skills for that. And so over the last year or so, Herb and others, including me, have been sort of concocting what a foundation would be, non-profit, not tied to any of the organizations that are involved in C++, and basically try to get the information out there, because we have not been very good at that. We've had no outlets, and too often we've heard that C++ wasn't doing this or wasn't doing that, or was dying or wasn't there anymore, and nobody was using it, when we knew for a fact that millions of people were using it, and there was lots of interesting news, but no channels. So the C++ Foundation is supposed to look into helping C++ in general, and the website is supposed to be an outlet for information about C++.
And everyone can, if you're watching this, you can go to isocpp.org. You can click on register and join, and there are industry sponsors in addition. So that's great to have that resource out there, and lots of links to lots of information. Today we're going to have a conversation about the C++ language, the C++ standard, how it builds on C++, how C++ 11 builds on it, makes it easier to learn, use, and teach. Those were some of the goals for C++ 11. Talk somewhat about application portability, and as Bjarne mentioned, there are millions of people using C++, and he has lots of examples to pull from about how C++ is used in infrastructure, in industry, by the government, by major software vendors, and so on. It's an interesting note too, Bjarne, today would have been the 197th birthday of Ada Lovelace, the world's quote-unquote first programmer, and Google has a doodle to celebrate that. So it's a historic note.
Yeah, sure. Yes.
And now I remember back many years ago when we would be on panels at software development conferences and such, and I was talking about Object Pascal and you were talking about C++, and questions would come up about when should C++ be some kind of standard, ANSI standard, ISO standard, and I remember you had some comments way back then, not only about when a standards effort should start for C++, but also you had years now of experience in working with others from industry, academia, and other interested parties on C++. What was all that like, and what is it still like today?
Let's see, it took some nudging, arm twisting to get me on board to realize that it was actually time to start a standards effort. Sort of people from Sun and HP and IBM and places like that pointed out to me that you couldn't have a language that was used by millions and that the infrastructure of major corporations depended on be controlled by a single guy in a single company, because, well, even if you could trust the guy, you can't trust the corporation. And so I was a bit sad, because that meant that those things I could not do and the things I wanted to do would take years instead of months, because you had to build up consensus, you had to get everybody to agree, and then you had to wait for 5 compilers to catch up, as opposed to just disappearing for a couple of weeks and doing it. On the other hand, the fundamental argument is correct. If you want something that is really widely useful, you need some kind of standard. As languages grow, if they're owned by a single corporation, sooner or later they start taking on peculiar twists to support that organization's business plan, and the allies of that corporation are favored, and people who are not allies have trouble actually using the stuff. Today we can look at languages that we were talking about back in, well, 20, 25 years ago. Most of them aren't here anymore. And a lot of the languages that are seen as competitors to C++ are owned by a single corporation, and has the benefit of being backed by a corporation, but they do tend to fight with all the other corporations. Portability is a really hard thing to achieve these days. It's always been difficult, but it's not getting any easier. And I think portability across platforms is a very big deal for a lot of people.
Yeah, I can imagine if everybody was building their own C++ compilers the way they wanted, it would be total chaos.
Well, they'll build their C++-like compilers the way they wanted. Of course, people are doing something like that anyway, especially in the GUI area, and that's a problem, big problem. But there's a huge core of a language and the library that is common, it is portable. So the huge parts of a system can be written independently of vendor extensions.
And maybe I'll skip to this one. There's always that question of what is C++ after all, right? So maybe you have some thoughts. I mean, these are all your thoughts. I think this is
from a talk I give. I write a new talk every year, 2 years, which I think of about as my broad spectrum talk, which I give to people who are not supposed to be C++ experts, but get an idea of what C++ is. And the point of this slide with the wise men and the elephant is that often I feel I'm the only one who doesn't know what C++ is. Everybody else have seen part of the elephant and are very sure they know what the elephant is, but they haven't seen the whole beast. And part of my job, as I see it today, is to try and determine what is the beast and how do you present it and how you explain it and how do you tell people how to actually use C++ well, instead of getting sort of trapped into a corner of the language. Of course you can write basically pure C in C++, but why would you want to? Similarly, you can write pure object-oriented programming in C++, but why would you want to? It's not optimal. There's people these days that wants everything to be template metaprogramming. Well, template metaprogramming, generic programming is really useful in some areas, but it's certainly not everything. And so my job is to explain that elephant, is to try and show how things fit together, why C++ is a synthesis of ideas and features as opposed to a collection of unrelated features.
Yep, and you have another slide which sort of goes through some of the history of programming languages and where C++ and C++11 fit. Maybe you'd have a few words to talk about some of the influences on you.
Sure. This is the really, really fundamental one. It shows two lines of development that led to C++. The bottom line has to do with how do you use hardware well? How do you get every cycle out of the hardware? How do you maintain that contest? And it comes from assembler through BCPL and C and into the parts of C++ that is connected directly to hardware. And I'd like to point out that there's progress in that line. Things like const exploit in C++ today, we can do things that and do things better than could be done in C. It's not just a static thing where you get the same every decade. The top line is something that's more interesting. This is where people figured out they could build domain-specific abstractions into languages. So Fortran built into a language what engineers were doing on their whiteboards, blackboards in those days. And what the COBOL programmers, when they saw that, wanted something that sort of business people had on their blackboards and boardrooms and things like that. And so basically they lifted the idea of programming from the hardware into the domain of humans, use human languages. And so that's John Backus there with Fortran. The one in the middle over Simula is a key person in this whole game. That is Christian Nygaard, who was one of the designers of Simula. He was the one that brought classes into programming, and especially inheritance, derived classes, virtual functions, all of that stuff comes from his work. And basically the idea was that we got all of these domain-specific abstractions, which was good if you stuck in one domain. But people who were in several domains now had a huge problem. If you wanted to do some computation on data in a database, you couldn't do it because computations were Fortran and databases were COBOL. And so Christian thought, why can't we build into a language the mechanisms for expressing domain-specific abstractions? And that's what classes and class hierarchies are. And so I borrowed that idea. And the synthesis that is C++ and is improving goes with the object-oriented things. Think of them as abstractions. There's the generic programming that comes from the same idea, and then there's the hardware line of thought. By the way, the assembler guy down there is David Wheeler, my thesis advisor in Cambridge, who's one of the 10 people in the world who can claim to have written the first compiler, and he wrote the first program ever to run on a stored program computer. And of course there's Dennis Ritchie, my colleague from Bell Labs, OOC.
And you're often asked, is there a one sentence or one sentence fragment that describes or is a description of the C++ language? Maybe you can mention how you came up.
I always try, and it shows why I should not be in marketing. I tried with a lightweight abstraction programming language, trying to capture the idea that we start out from the hardware and we build abstractions, we can afford to build abstractions, and we can work our way into something that's really elegant and still efficient. I've been trying to identify the key strengths of C++, and I think they're in software infrastructure. They are there when you have resource-constrained applications. This is where elegance and efficiency are simultaneously needed. Of course, C++ is generally useful. It's a general-purpose programming language, but you know, every language can do, say, expensive abstraction, and essentially all languages can do application development if there's no connection to software infrastructure, if there's no constraints on the hardware, the capacity, the energy usage, and things like that. So see this not as an attempt to limit where C++ can be used, but as an attempt to distill what is special about it, what it can do better than anybody else.
Yeah, and this slide I stuck in just, you know, C++ is best for building, and you could list any number of types of systems, application architectures, and ultimately it's really all the above and more, right?
That all of the above and more is the correct answer here. It's there for really bit and byte fiddling stuff deep in the network stack or in the microcode of things, and then there's applications. I guess this year is not the one to point out that essentially all high-speed trading and most of Wall Street is C++. We could point out, let's see, there's a picture of that engine there. It's one of the world's largest marine engines. There's an engine here by cylinder head number 5. That'll give you an idea of the size. And of course, the engine control is C++. All of these pictures have something to do with C++. Let's see, down at the bottom we have bits of the Large Hadron Collider. It's one of the experiments there. We've got the Higgs boson now. Hey, this is good. I love when C++ is being used for something sort of ambitious and scientific. And then we have a whole bunch of well-known C++ applications. I just put their logos in here. When people get into these stupid language wars, like what's best, C++ or Java, I can't be that rude about C++ applications. And, well, most of the major Java implementations are C++. Same with C#. Same with the browsers and such. It's a big world, and many languages are useful.
And we'll come back in a little bit to some other applications, and you have a link on your stroustrup.com page to a whole list of types of applications.
There's a lot of applications, and I can't keep up with them. So please remember, my list of applications is always way behind reality, both in size, complexity, and newness.
Now, one of the goals of C++11 that was stated was doing things to help make C++ easier to learn. And I took a quote from your ETAPS 2012 keynote from earlier this year, where you said C++ is a large and complicated language, but to write good C++, you only need to understand a few fundamental techniques. What are some of those fundamental techniques for everyone?
Let me just go off on the sidetrack for a second. We're emphasizing that C++ is used in many, many areas and in a range of applications that's beyond anybody's imagination. So I'm clearly focused on sort of industrial uses of C++, and I have a weak spot for engineering applications and scientific applications, and C++ is not the most academic of languages. ETAPS is the European conference on basically theory of programming languages. So, whoops, right into the opposite camp, and it's used everywhere. Now, a lot of people look at C++ and they want to understand every little dark corner. This is what you do if you want to be a language lawyer or a compiler writer or a test suite writer. But most people should actually try not to do that. They should look at what is the easiest way of writing a good solution to my problem. And so I'm trying to focus on things that leads to correct programs fairly easy. I emphasize the use of constructors to establish invariants, to acquire resources, destructors for cleaning up, copy operations, copy constructors, copy assignments, that is, for making copies, and the new move semantics that allows you to move an object out of a scope and into another one very cheaply. So one of the things that was limiting C++ 98 was that we could build really good resource handles like vector or livestream or thread, but they were hard to move around because, well, this is computers and everybody knows that we copy things, except in the real world we don't copy things. If I want to lend you my phone, I don't make a copy of my phone and give it to you and destroy my old copy so that we don't get into trouble with the phone company. I just hand the phone over to you, right? I move it. I don't copy it. And we can do the same in C++ now. So if I make myself a, say, 10,000 by 10,000 matrix in a function, I can hand it over to you at the cost of 2 pointer assignments. I mean, we're talking picoseconds here. And that is a huge difference in the way I can write code today. And I think this is probably the best example of how you can write really elegant, simple C++. Because this view of the language with constructors, destructors, move and copy operations are integrated with the exception handling mechanism. When you hear the words RAII, resource acquisition is initialization, you get it hides the notion that you can integrate your error handling with your resource management. And again, that's an example of why I should not be let loose with marketing, because I came up with that phrase.
For me, I always look at data abstraction. I look at the objects or the classes that I try to build first and make sure those are really clean and clear. And yeah. I know you cover that in, we'll talk about that in a moment, in your tour of C++.
That's right. I look at it. How do you create them? What should happen when they go away? Can you copy them? And if so, how? Can you move them? And if so, how? And then I look at the details of what you can do with them. And that I separate into two parts. What actually needs to be a member and what can be done elsewhere. And so I put things into the interface only if it's essential for convenience or it needs access to the implementation. Other things I would like to have separate so that I don't get classes with sort of the kitchen sink design, where everything that anybody might possibly have wanted are inside the class, because that makes maintenance a real pain. You can't make any changes without looking at 50 functions and such. That's not good.
And I put at the bottom here, one of the questions, not only for students to learn and everybody to learn, is also people are always wanting to learn good C++ style and technique. I know that when Scott Myers was giving talks at developer conferences, those would be very well attended. And you also pointed on your website to some additional coding standards or ideas, right?
Yeah. The Joint Strike Fighter standard was one I was involved in. And that's a good example of a very specialized standard. People always want to simplify the language to do exactly what they want. But to be part of a huge global and multi-industry community, the language has to support things you would never do in your field. And therefore, I see this language as a general purpose tool, and you see the coding standards as specifying what you can do in a specific domain. So the Joint Strike Fighter rules is if you are writing flight control software that needs hard real-time deadlines, a hard real-time response, and where well, people die if you get it wrong. Very, very strict. I think one thing that people forget, Southern Interest School rarely forgets it, but most people forget that they are writing coding standards for a specific domain. And they want to write a coding standard that makes everybody write code the way they like to write code. And they forget that they don't know anything about most people's way of writing code. And they don't know hardly anything about the vast majority of programmers need, because they're just broader than any one individual. So you need coding standards in the plural, not just one. And I would like to add to this list two things. One that's easy to find, it was on this ISO CPP site. There's something called the tour, which is, once I get it finished, the first 4 chapters of the C++ programming language, the 4th edition, which basically takes you through the features with an emphasis of what I consider important. And that is a reasonable way to look at things if you're already a programmer. I've got the basics and the abstraction mechanisms. The next 2 chapters will be about the standard library. And then hopefully once I've got those in, we can get the book itself. You can see the picture there on the screen. Get that book out and used. Now, if you are not a programmer already, especially if you're not an experienced programmer in sort of the C++, C world, you might do well to go back and look at programming again in the context of C++. And that's what the book Programming Principles and Practice Using C++ is about. I wrote it because I were a little bit too vocal about the quality of introductory programming teaching at Texas A&M when I was here, and so they quite reasonably put me in charge of it. And for about 2 weeks, I was looking through C++ textbooks and had smoke coming out of my ears and was muttering things like, if that's C++, I don't like it either. And I think that actually the quality of teaching with C++ has gone down over the last 10, 15 years. And it's gone away from how do you write a good program and what's a good program, how do you recognize it, what's wrong with a bad program, to here this long list of features that you should understand. It's so easy to teach the list of features, it's so easy to test the list of features, and conversely it is really hard to teach how to write good programming and how to recognize a good program when you see one. And so the programming book was trying to address that and has had some success. Of course, it's not perfect, no book, of course, can be. So read that book. It might be good for you. And the slides are available on my homepage, so you can see what people are teaching from, not just at Tamil, but in quite a few places, more places than I know of. Ever so often I hear about a new course somewhere in the world that's using it. And like my other books, they're widely translated. I think I've got 7 or 8 translations of PPP, or the Swan book as it's called, and I've got 19 translations of the C++ programming language.
Yeah. So I wanted to put a few questions together. Maybe you can just look at this in total and have a conversation more about, what is in C++ 11 makes C++ easier to use was one of the key goals. Again, easier to learn now, easier to use.
Yeah, I would emphasize the move semantics, the ability to move objects around. That saves you from using pointers in many, many cases. And actually it also allows you to make smart pointers. So if you need pointer semantics, you can use a unique pointer or a shared pointer. But basically, pointers don't belong in interfaces. You don't need them anymore. They belong deep into abstractions that are resource handles. Many examples are vectors and lists and maps and unordered maps, hash tables, that is, threads, locks, you name it. And all of these things, by the way, are in the standard library today. So one thing that you get from C++ 11 is the new libraries. So if you want a hash table, don't go and write one yourself. One of my aims for years was never to have to write another hash table. And so today I tend to use vector a whole lot, maps quite a lot, and unordered maps, the hash tables, a fair bit. And you can do multi-threading in a type-safe manner. That's a big deal. The concurrency support in C++ is not in sort of fundamentally different from the support we've had for the last 20 years for threads and such, but it's type safe. So it's like going from assembly code to C++. And that's a big deal. So you get the familiar abstractions, the familiar way of talking about threads and locks, and you get it at a modern level of expression.
I think it was in a talk earlier this year, maybe it was the Going Native talk at Microsoft's conference. Somebody asked about inheritance, and I put the question here, is inheritance overused, and how should we guide developers in the use of inheritance?
Well, it's obviously overused. It's obviously hugely overused. There are languages where you can't express yourself without inheritance, and then everything becomes, well, inheritance. And they fit everything into a hierarchy. Quite often they fit everything into a single hierarchy, and it doesn't make any sense. For instance, I have never needed a container that could hold anything, because if it holds anything, I don't know what to do about it. I can use containers of numbers, I can use containers of shapes, I can use containers of hardware pieces, I can use containers of, engine controllers. But totally building everything into a single hierarchy just creates chaos. It moves type checking from compile time to runtime, which is very convenient when you are hacking a piece of code together fast, and it's a nightmare if you want to develop quality code, because you can't test it right. And that's a side effect of stronger type checking. You get performance. But basically, inheritance are dramatically overused. And how we guide them is a much, much harder question. I think your question here, deep, shallow, or somewhere in between actually shows the problem more than the answer. Because inheritance should come from the domain, from the problem. So if you look at where inheritance is good, it's things where there is kind of relationship in the fundamental domain. Shapes and GUI fits into this. Parts of GUI are better actually with some containment, but there's something natural there. Similarly, device controllers have natural hierarchies that you should exploit. And I think very often, if you forget about programming languages for a while, look at the application domain, the questions about deep, shallow, or somewhere in between answer themselves. I also think we should think very hard when we talk about inheritance about the distinction between implementation inheritance, where in some sense you want deep hierarchies so that most of implementation can be shared, and interface inheritance, where you don't care. All you want to do is to hide an implementation or a set of implementations behind a common interface. And I don't think people distinguish that enough. Now, one of the really nice things about Java, probably the one thing I really appreciate, is the fact that they use the keyword interface to describe interfaces, what in C++ are pure abstract classes. And I wish I'd had that idea, and it would have made teaching very much easier. That is interface inheritance, and every language that has interfaces, every language that has static checking of class hierarchies have multiple inheritance of interfaces. Implementation inheritance is another matter, and it is an implementation detail very often. I think calling a pure abstract class an interface was a stroke of genius of the same kind and order as my idea of borrowing the word class from Simula rather than just working on with struct from C, which is perfectly all right technically, but I would never be able to teach people to use the new stuff in new ways. Sometimes you need a name. Sometimes you need to have a label that you can stick on the new stuff.
Yep, and you mentioned in several talks, and especially earlier this year when I think someone was asking you a question about properties and getters and setters and data access inside of classes, and you made the comment that you favored having public or private data inside classes, and C++ has protected, I guess, as well. But maybe you can share a few thoughts on why for you public and private seem to be enough.
Yeah. Again, it depends on what you're doing. And most of the things I'm doing, I don't need protected. But you will find examples of protected in the C++ programming language, the book, and I have not taken them out. It mostly has to do with the fact that when you build big hierarchies, you get two kinds of users. You get the implementers. Sorry, you have the implementers, and they have two kinds of users, the general users and the people who extend the hierarchy. And people who extend the hierarchy often often need protected access, at least to the functions. Now, the reason I like public-private is that with private, nobody can mess with it. So I can establish an invariant in a constructor and maintain it, and that means that I, as an implementer, don't have to worry anymore. If I say protected about some data, anybody can mess with it. So you can come around tomorrow, derive a class, and scramble my protected data. And that was a problem, has been a problem for anybody who has had it. It is not a problem if the it's not so much of a problem if the protected interface really is functional. That is, there's a whole set of functions that you can use, and you've just provided support for implementers of new classes as opposed to messing around with the user interface. If you follow that rule also, you will see that you don't get anywhere near as much casting type conversion from base to derived, because the user interface is defined with interface inheritance fairly close to the base of the hierarchy, and the fact that there's changes in the interface provided to implementers, a protected interface, shouldn't bother the users, and they shouldn't see it, and they shouldn't use it. I mean, when you get access to private data, you're responsible for everything. If protected gives you access to something that the general users don't have access to, you become dependent on more, and the code has been more intertwined and harder to maintain. So the idea is public-private, and sometimes out of necessity, we use protected.
And I stuck this other question in here because I found a paper that you had from this year about macros are still around, coming from C, and people use them, but maybe there's a better way in C++ to use the term demacrofication of your applications. Some thoughts perhaps on what to use instead of macros.
Yeah, I mean, for most users of macros, there's something better in C++. The exceptions are things like source code control using sharp-if and sharp-if-def. This will stay that way until we get some kind of module system. The other use for macros that gives a lot of macros is portability. People want to if-def based on what bugs their compiler has and what platform they're on. The platform things are, again, source code control. It's modularity. But the others, bugs and implementation weaknesses, not just in the language, but in the various libraries, is a major source of macros, and macros are a major source of bugs. But I'm not so worried about the simple if-defs. I'm worried about real macros that expand into code, and they don't follow the rules of C++ or any other language. They are text manipulation, features. They make tool building harder. I needn't tell that to you because you build tools. And they have delayed lots of progress in C++ because it's very hard to deal with a language with a lot of macros. So some people agree with me on this. A lot of people agree with me on this, not everybody. But even people who agree then scratch their heads and says, well, my program has 10,000 macros. I can't touch them. After all, they're really ugly and they do ugly things and they're scope dependent. They are scope independent and they pick up random names and I don't know what they were meant to do. I do not know how to fix code. I can't take a macro away. It's too dangerous. And so I said, well, maybe we can analyze programs and automatically remove macros that doesn't do anything so interesting that they are dangerous to remove. And furthermore, if a macro is so complicated and dangerous that you can't understand it, that my program can't understand it, maybe it should be flagged for programmer attention. So this tool here, which was done by one of my students with the help from one of my postdoc, was let's go and see what we can deal with automatically. And the things that we can't deal with automatically, we call on a human. We're still smarter than most programs. And so that was what that work was about. And we built a tool and we removed automatically in a range of programs, I think. We always did better than about 50%, 60%, and up to the high 90s. And this was a student project in a university. I hope somebody takes this idea and runs with it and does it with industrial strength and industrial competence. And then we can start seeing programs that actually look the way they do in textbooks.
You were asked earlier this year at a conference about teaching the language, and you already mentioned your textbook, but do you have some advice? Because we have some students, I'm sure, that are listening and are on this session. Should students start with a subset? Should they avoid parts of the language? And you had some comments earlier that I put quotes at the top, but
yeah, my considered answer for that is that textbook. That's when I had to face that question, have to come up with an answer where it actually mattered to thousands of students. And of course you have to start with a subset. Because, I mean, on day one, how much can you do? Well, you can do Hello World or maybe Hello David or something like that. And then the next day you have to do something else. I think what's wrong with the subsetting idea is that people get this idea that it has to be a bottom-up subset. You have to do all of C first. So you have to learn all the workarounds for the lack of features. And you have to learn all the dirty tricks for how to survive with macros and arrays. No, that's not the right way. So the subset you choose, for me, it's I decided, well, you need some types: bool, char, int, double, and string. And the next type I'll give you is vector. And in chapter 17, several months later, you will actually get pointers and arrays. So you have to be very careful how you build up things. And the subset that you should work with is something that allows you to do useful things reasonably early and is reasonably clean. And as you notice, my first 5 types, one of them is actually not a built-in type. It's a standard library facility, the string. And number 6 is the vector. And one of the first things I do with vector is pushback, because I don't really want people to start laying off a lot of uninitialized objects and filling them and running over the edge of a fixed size structure and all of that stuff. No, that's later. So you need standard library facilities very early on. I could do a better job in C++11, but I haven't had time to get around to doing it. The what should we teach software developers is a philosophical discussion, somewhat academic, but it's about that. The book is a concrete example of how you can do it. Excellent. And it sort of worked.
There was a great article that you pointed me to, and I read earlier this year in IEEE Computer, and it's also available as a PDF from your site. And the title was Software Development for Infrastructure. And, the demand for reliable software that industry and the markets need. What should be some of the important takeaways? And I have some bullets from some of your slides as well.
I'm tiring. Why don't you tell me?
Oh, okay. Well, you had already mentioned it, building reliable systems, making sure that you look at trade-offs if you have to for time, power, completion of the software, what's in your team, what skills do they have. Of course, you mentioned that there's sort of extreme cases, people that shove software out there into the market because they want to be first in a category, first on a device. But what happens, in many cases, if you're playing some game on your smartphone that's built in C++, if it crashes, you just start up the game again and go. Tough. But you mentioned earlier in things like the Joint Strike Fighter, or I use the term life-critical systems, could be patient monitoring.
I mean, I mentioned in the article that the infrastructure for keeping your smartphone running, the update system, the operating system, the 911 software for the phone, is in the life-critical category, because if the phone suddenly doesn't work when you need an ambulance, that's not good. And on the picture before, those were wind turbines, and they are programmed in C++, and they are big, expensive things, and if they don't work, they spin out of control and crash. If they're on land, they can take people with them. And one thing I noticed is that efficiency, in the good old-fashioned way of not wasting too much time or space on a computer, when you take that to a cell phone, it becomes battery life and responsiveness. And if you take it to server farms, well, it becomes heat and cost. And so the efficiency of C++ compared to the obvious alternatives is sort of many gigawatts a year. And so I made some contribution to the fight against global warming, and feel good about that. It's like when I look at the science stuff, I didn't do it myself, but I helped.
Yep. And this slide has some of the things that you talked about, is it safe, and life, mission, business critical systems. And you talked about hard real-time systems and what is in C++ that maybe might have to be considered in a hard real-time system or a life-critical system. Right.
Yeah, the "is it safe" quote is we're sitting around a table deciding a set of rules for a system. And the safety guy gave us a lecture every morning where he explained that "is it safe" means if you say no, somebody dies. And every about half hour to an hour, he asked that question just to keep us on our toes. So this is not your average system, but if you're building a trading system on Wall Street, you can blow $500 million in a few milliseconds. You better not do it, because if that happens, lots of people will get hurt in a very bad way, not physically immediately, but the social consequences of a mistake like that will destroy families and individuals. So you have to, I think more about reliability these days. But anyway, the next thing for the life mission critical systems, if you have hard real time, all the systems that we're using today that has hard real time, that is, you must respond in 10 milliseconds or 100 microseconds or something like that, has rules against using new and delete They can't use exceptions. I'm very sad about that. It's not a fundamental issue, it's a tool issue. And they can't use dynamic cast as it's currently implemented. I have a paper showing how to do a dynamic cast that is low constant time, so you can use it in this world. But you don't take your average non-embedded system C++ compiler and try that. So some of it is tools. And let's give an example so that people can understand it. If you use new and delete, say on a space probe or a plane, eventually you are going to get some fragmentation. That means that the cost of allocating a new object becomes unpredictable. Because if there's a lot of fragmentation, it takes much longer than when you just started your run. And after a few hours or a few years, you run out of memory. That's not acceptable in the kind of aerospace applications I'm thinking about. Now, you can take away delete. You can't get fragmentation anymore. So usually new is allowed before takeoff, quite literally. You can allocate stuff. And similarly, stack allocators and pool allocators are allowed because they can't fragment and you can easily control their research usage. So this is an example of how to analyze a particular application domain and then coming up with rules for that application domain. I think everybody should consider where in their business, in their company, what is the underlying hard requirements, and then make those part of the rule set for the programming, as opposed to looking at language features and saying, I don't like that one, or I like that one. That's the wrong way of going about it. You analyze the fundamentals, and then you see how the language reflects it.
Yeah. I'm going to skip forward because of time, but I'll make sure that I get these slides in PDF form for all the attendees. There's been questions about what's the future for the C++ language, what's the future for the standard? What's cooking in the lab, sometimes people will say.
Okay, we're actually being very ambitious. There's going to be a minor release in 14 and a major release in 17. And so I'm actually working on what does C++ 14 look like. And my definition is it's something that completes C++ 11. There are things you can't do without experience. And we made a few mistakes. And we failed to make very minor changes that could have made life much easier. A good example is polymorphic lambdas, generic lambdas. We will almost certainly get that in 14. We have a discussion about whether we can do the interface checking for template arguments. We can't do full concepts, but can we do a lightweight thing that just checks users? I think the answer is yes. And so we're looking at some minor features that makes the C++ 11 styles of programming better. There may be some libraries also. And then in 17, we have a bunch of study groups that are studying where the language might go. If all of those study groups completed and we took everything that was in it, total chaos would erupt because we couldn't absorb that much. But some of it will come in. So if you go to ISO C++ and look at the standards, you can look at the study groups. There's a list of where work is being done. And then that's massive. In most places you can think of, we're doing something.
Excellent. I'm going to skip forward now. There's a few questions that came up in advance, so I thought I'd go through those from the attendees, and then we'll take a look, and then we'll finish the top of the hour. And again, thank you very much for spending your valuable time with us today. Mm-hmm. Michael asked, did you expect C++ to become this popular, and are you happy with the evolution?
Of course not, with the popularity. I needed a tool for me, and then with me and my friends, and then I at some point decided that I'd gotten myself into a really bad situation with a medium success. And so I started calculating what it would take to get me out of the trouble. which was, how do you have enough users so that I don't do all the implementation and porting anymore? And I came to the conclusion I needed 5,000 users, and I sort of overshot that. About the evolution, of course, I'm not happy with any of the details, and the standards work is very painful, frustrating kind of work, but it's necessary. And there's absolutely no doubt that C++ 11 is far better than the previous versions. So in that sense, yeah, we're doing all right, and we're moving in the right direction. I would like to see more things in some areas, many more interesting things, and there's things I would like not to have happen, but I can't get everything. I know that. I mean, there's things I'm working on now, like functional programming style pattern matching to get rid of all of those visitor patterns, which I don't like. I would like to see better support for generic programming, the concepts idea. It got far too complicated in C++ OX. So if we can do the same thing and better in 10% of the language rules and get the compilers run faster, yeah, I want that. And so there's a very long list of things I would like to get. This is not the end of the road. We can do much better, and I think we will.
And Ahmed asks, do you think the future of C++ language is going to be brighter than ever? And if yes, why and how?
Oh, it's so difficult. I mean, endless sages have said it's hard to predict the future. And I think, first of all, C++ is not going away. It's deeply embedded in our infrastructure. But I also think that it's not just going to be one of these legacy languages, the walking dead, because it has strengths that nobody else has, and it has a very lively community, and new things are coming all the time. So I think that branching out from its core strength in systems programming, embedded systems, infrastructure, it'll do all kinds of things. I believe you have a talk later today saying it's not just infrastructure, which I suspect is an answer to my article. And of course he's right. C++ will be in many things, but it'll come first in infrastructure systems programming, then in systems that has a systems programming component, and then into things where its elegance and efficiency and maintainability and large tool support structure will help.
And I think you mentioned just a couple seconds ago, maybe some hints of things of some of the work that you're doing, but Cephalov asks, OOP has been around for more than 40 years now. Do you think there are any programming paradigm alternatives to OOP on the horizon? Or
I hate the word paradigm.
Okay.
If you go back to the origins of it from Kuhn, it assumes that there's a total overthrow of what's previous stuff, and something brand new comes in that changes it. I don't think there's ever been such a paradigm shift, not even in physics where they took it from. What happens is that the good ideas of old stuff get incorporated in new stuff. So we got OOP, as it's called, object-based programming, as Christian Nygaard called it when he invented it in '67 or thereabouts. It absorbed some of the ideas from data abstraction, which didn't have inheritance. And it had weaknesses when it came to generic algorithms. It's really hard to write an object-oriented program that deals very well with ints and floats and doubles at the performance needed for say, physics calculations. And so you get generic programming. And I think that what comes next is not an alternative. It's a new synthesis that takes in new components. And I don't have a sort of, say, a new buzzword that's coming in. But we have data abstraction, we have class hierarchies, object-oriented programming, we have generic programming, And I think concurrency is driving a lot of the thoughts about how to use things and how to express things. And that's where we are going to see new things. But object-oriented programming is not going to go away. Yep. Christian Nygaard said, you know, when you ask me this question, I point out that plus and minus has been around for a long time. And there are these people who invented multiply and divide and think that's much, much cooler. But you know, plus and minus doesn't go away. They're useful. And in the same way that data abstraction without hierarchies didn't go away just because they invented class hierarchies will not go away just because we invented generic programming, and none of these will go away whatever we come up with next.
Yeah, you mentioned you were doing some looking at functional programming and some of its aspects as well.
Yeah. There's a lot of good in functional programming, but they tend to work only for functional programming. And they tend to work only in very isolated tool areas. It's interesting to see that C++ wins, C++ programs wins the international functional programming context every 2 or 3 years. And there's always a C++ program in sort of the top 3 or 4, which wasn't supposed to happen. And I think we have to learn from the strength of the functional programming community and be rather careful with what we borrow, because they've owned huge chunks of the educational and research establishment for the last 30 years, and the number of programs that's actually been shipped doing useful things are remarkably close to 0. So there's something they didn't get right. So we have to try and learn from them, but also try not to fall into the problems that they have had.
And then one more question, because we're at the top of the hour, and again, thank you very much. James Cosen asked, what do you think of the newer ambiguous types defined in C++11? I think they are powerful, but may turn out to be more dangerous than pointers were in the early days of C.
The what?
Newer ambiguous types defined in C++?
I have no idea what he's talking about.
Yeah. Okay. All right.
There are definitely things in C++11 that are powerful and therefore can be dangerous, especially in the hands of amateurs. And we'll have to learn and see how to deal with it. There are things in C that people predicted very confidently nobody could ever live with it, would never be a success. It was a total failure. I put the state of the art back 5 years or 10. And of course they were wrong, because we also learned how not to get into the problems. The same will happen.
Yeah. And Bjarne, thank you so much for spending this hour with all of us. Thank you for all the years of your dedication to the C++ language. And as always, we're doing this over the internet, but it's always great when we bump into each other at a conference or somewhere. Maybe it'll be nice. Sometime.
Well, we're using a lot of C++ to do this, of course, and thanks a lot for your efforts. You've been around for a long time and provided some really nice tools. I remember the early days. You did a lot, and you're doing it again. Thank you.
Yeah, no, we're doing it, and just. I know you don't care about U.S. football very much, but I guess the buzz on Texas A&M University campus is about Johnny Football winning the Heisman
Trophy. We have some good football players here.
Yeah. Okay. But, take care, Bjarne. Thank you very much.
Thanks. Bye.